Solving and classifying linear equations in one variable. Southwestern College, Professor Maria Olivas. Solving and classifying linear equations in one variable. Objectives. Solve linear equations in one variable. Classify linear equations in one variable. Solving linear equations in one variable. The goal of solving linear equations is to find the value of the variable that will make the statement or equation true. We do this by performing operations to both sides of the equation in order to isolate the variable. In other words, we want to get the variable by itself with a coefficient of 1 on one side of the equation. A linear equation in one variable is an equation in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. The solution of a linear equation is the value or values of the variable that make the equation a true statement. The set of all solutions of an equation is called the solution set. In order for us to solve linear equations, we do need to learn about properties of equality. So let's go over a few of our properties of equality next. Properties of equality. Linear equations in one variable are solved by applying these key properties of equality. Let a, b, and c represent real numbers. What you see here is you see a chart, and we have 4 properties of equality going across the top of each one of these 4 columns in this chart. We have the addition property of equality, the subtraction property of equality, the multiplication property of equality, the division property of equality. Let's start off by writing in first the addition property of equality. So the addition property of equality states that if we have a linear equation of the form a equal to b, then a plus c is going to be equal to b plus c. This means we're allowed to add the same quantity to both sides of the equal sign. In the subtraction property of equality, if a is equal to b, then a minus c is going to be equal to b minus c. We are allowed to subtract the same quantity from both sides of the equal sign. And in the multiplication property of equality, if a equals b, then a times c is going to be equal to b times c. We are allowed to multiply the same quantity to both sides of the equal sign. And in the division property of equality, if a equals b, then a divided by c is going to be equal to b divided by c, provided that c is not equal to 0. I will be applying these 4 key properties of equalities in the examples that I will be doing later on in this video. Let's go on to classifying linear equations as identity, conditional, or contradiction. A conditional equation is an equation that is true for some values of the variable and false for other values of the variable. A contradiction is an equation that is false for every replacement value of the variable. Contradictions have no solution, so the solution set is the empty set, written as an empty set of braces or a 0 with a slash through it. An identity is an equation that is satisfied for all values of the variables for which both sides of the equation are defined. The solution set of linear identities is the set of all real numbers. Let's go ahead and solve some examples. Solve each equation. State whether the equation is a contradiction, an identity, or a conditional equation. Number 1. 5y minus 7 equals 2y plus 19. Let's begin by rewriting the equation. So I'm going to go ahead and write out 5y minus 7 equals 2y plus 19. We want to get all of our y terms to one side of the equation, so I'm going to subtract 2y to both sides of the equal sign. On the right-hand side, they will zero out when you add them up, and on the left-hand side, 5y minus 2y will give me 3y, and then we're just going to continue writing the rest of the equation, so that would be minus 7 equals 19. Now let's add 7 to both sides to isolate the variable. We are applying our addition property of equality here. The 7s are going to zero out on the left-hand side, and we're going to be left with 3y equals 26. Now, since there is a 3 being multiplied to the y and we want to isolate that y, we're going to divide by 3 to both sides of our equation. The 3's are going to divide out, and we will end up with a coefficient of 1 in front of the y, and we will have y is equal to 26 thirds. So we can go ahead and write this as our solution. I'm going to go ahead and box that in. We could also write that inside a set of braces to represent a solution set. And now I'm going to go ahead and box each of those answers in. Either one of those is fine to represent the solution. I am underlining in the directions, state whether the equation is a contradiction, an identity, or a conditional equation. Because this actually had a solution, this is a conditional equation. It had one solution. If you were to try to substitute any other value, it would come out false. But this is the one solution, this 26 thirds, which will make the statement true if you were to substitute it back into the equation, which you can do to check your solution. I have gone ahead and written down the words conditional equation, and I boxed those words in. Let's go on to our second example here. Example 2. 3x minus 4, we're going to open up a set of parentheses. Inside the parentheses, we're going to have 2x plus 1, close the parentheses, equals 8x minus 1 plus x. We're going to begin by distributing the negative 4 that is in front of the set of parentheses. So we're going to end up with 3x minus 8x minus 4 equals 8x minus 1 plus x. Let's go ahead and combine like terms. On the left-hand side of the equal sign, we can combine the 3x minus 8x, and we will get negative 5x minus 4 equals, I can combine 8x with positive x, and that'll give me 9x minus 1. I'm going to subtract 9x from both sides to get all my x terms on one side of the equal sign. On the right-hand side, they will zero out the x terms, and I will be left with negative 4x minus 4 equals negative 1. Now, in order to isolate our variable, we are going to need to add 4 to both sides of our equal sign. I'm going to go ahead and draw an arrow here that's pointing upward and towards the right so I can rewrite my equation. I'm going to rewrite negative 14x minus 4 equals negative 1. I'm going to add 4 to both sides of the equal sign. The negative 4 and the positive 4 will zero out on the left-hand side, and we will be left with negative 14x equals 3. I'm going to divide both sides by negative 14. The negative 14s will divide out on the left-hand side, and I'll be left with a coefficient of 1 in front of the x, so I will have x equals negative 3/14. And I can also write this answer inside a set of braces to represent a solution set. So I can write it this way as x equals negative 3/14, and I'm going to box that in, or I can also write it as a solution set. And I'm going to open up a set of braces. Inside the braces, I'm going to write negative 3/14, and I'm going to close the braces. And I'm also going to box this in. This is my solution set. This example also represents a conditional equation. So I'm going to write down the words conditional equation to classify this type of equation, and I'm going to box conditional equation in. Example number 3. 4 times, we're going to open up a set of parentheses. We're going to have x plus 2, close the parentheses, equals 6x minus, open up a set of parentheses, 2x minus 5, close the parentheses, plus 3. I'm going to distribute the 4 in front of the set of parentheses and the negative sign in front of the parentheses on the right-hand side. And we'll be left with 4x plus 8 equals 6x minus 2x plus 5 plus 3. Let's combine like terms. So I'm going to go ahead and just keep everything that's on the left-hand side of the equation the same. So I'm just going to copy that again, 4x plus 8. On the right-hand side, I'm going to combine the 6x minus 2x, which will give me 4x. And then I'm going to combine the 5 plus 3, which will give me 8. Here at this point, hopefully you can see that what we have on the left-hand side is completely equal to what we have on the right-hand side. But I'm going to keep going. I'm going to subtract 4x from both sides of my equation in an attempt to get all my x terms to one side. But if you notice here, all of my x terms cancel out. And I'm left with 8 equals 8. At this point, you need to ask yourself, are you left with a true statement or a false statement? 8 equal to 8 is a true statement. This means that the solution set for this particular linear equation in one variable is going to be the set of all real numbers. So now we need to write that down. So you could write down the words all real numbers as our solution, or we could also represent this in terms of set builder notation, and we can also represent this in terms of interval notation. Let me begin by just writing out the words true statement, because that is the first step. You do need to identify whether or not you are left with a true or false statement after you have attempted to combine all of your variable terms. I'm going to open up a set of braces, and I'm going to write x such that x is any real number. So this is how we could write this in terms of set builder notation. There's another way we could write this in set builder notation. I'm going to write down the word or, and then underneath that, I'm going to open up another set of braces here, the set of all x, such that x is an element of the set of real numbers. And here I'm using more of a symbol notation for the set builder notation. Or in interval notation, it would be the open interval from negative infinity to positive infinity. I'm going to box in each one of these options that you could use to write down this solution set. Now this type of equation, what would we classify this type of equation as? Let me first draw a horizontal line segment here. And another horizontal line segment here to separate example 3 from example 2 and example 4. And let's go ahead and make sure we write down the type of equation that we have here. We call this type of equation an identity. And let's go ahead and box that in. And now let's go on to example number 4. Example number 4 states 4y minus, we're going to open up a set of parentheses, 7y plus 2, close the parentheses, equals 9y minus 3, open up a set of parentheses, 4y minus 5. I'm going to distribute the minus sign in front of the set of parentheses on the left-hand side, and I'm going to distribute the negative 3 that's in front of the parentheses on the right-hand side. We're going to be left with 4y minus 7y minus 2 equals 9y minus 12y plus 15. We can simplify this to negative 3y minus 2 equals negative 3y plus 15. Now, if I attempt to combine all my variable terms here and I add 3y to both sides of my equal sign, I see that all of my y terms are going to zero out here. Since they all cancel out, we're going to be left with the statement -2 equals 15. At this point, you need to ask yourself, is this a true or false statement? This is a false statement. Since this is a false statement, this means that there is going to be no solution for this linear equation in one variable. In order to write down that solution, you could either write down the words no solution, or you could draw an empty set of braces, or you could also write down a 0 with a slash through it. The 0 with the slash through it represents the empty set, right? And the empty set of braces represents the empty set as well. I'm going to box in each one of those options. Now, what type of equation is this? How would we classify this linear equation in one variable? We would classify this as a contradiction. And I'm going to go ahead and box in that word contradiction as well. And that's going to be it for that problem.